Welcome to this explainer, where we tackle one of the most mind-bending mysteries of our existence, the expanding universe, and what exactly lies beyond its observable edge. I'm really thrilled you're here, because today we're embarking on a journey that pushes the absolute limits of human understanding. We've got some truly massive concepts to anchor today, so let's just jump right in.
So, think about this. If the universe contains absolutely everything, what exactly is it expanding into? It's a paradox that completely breaks our brains, right? We're always told the universe is growing, but human intuition demands that for something to grow, it needs empty space to grow into. To solve this cosmic mystery, we've got to trace the clues from the fiery singularity of the Big Bang all the way to the absolute bleeding edge of theoretical physics.
Part 1. The Cosmic Balloon and Expansion Basics.
Okay, let's dive into this by establishing the ground rules of what we actually know about our expanding reality. Because before we can figure out what's on the outside, we have to understand what's happening on the inside. Our starting line is roughly 13.8 billion years ago. Since the incredibly hot and dense singularity of the Big Bang, all of space has been stretching. It wasn't just an explosion in space, it was an explosion of space itself. And from that unimaginably small point, it's been growing and cooling ever since.
But how do we actually know this? Well, we know it because of something called redshift. Back in 1929, astronomer Edwin Hubble first proved this expansion by observing distant galaxies. He noticed that the light from these galaxies was being stretched out toward the red end of the light spectrum. But more importantly, he showed that the farther away a galaxy is from us, the faster it's receding. The very fabric of space between us and them is literally stretching out.
To really visualize this, physicists love to use the balloon analogy. Imagine dots drawn on a deflated balloon. As you blow air into it, the balloon's surface stretches, right? The distance between every single dot increases. From the perspective of any one dot, all the other dots are moving away. This means the universe doesn't necessarily need an outside edge or some empty room to expand into, because the three-dimensional fabric of space is simply expanding into itself.
Now, you might be wondering, exactly how fast is the universe expanding? When we ask this, we're looking at the Hubble constant. And current measurements show the universe expanding at a staggering 80,000 kilometers per hour per million light years. Because of this sheer speed, galaxies far enough away are receding from us faster than the speed of light, which creates an observable horizon we can literally never look past.
Section 2. The Dark Energy Engine and Cosmic Acceleration.
Logically, you'd think that all the gravity in the universe, from all the stars, the black holes, the massive galaxies, would eventually act like a giant brake, pulling everything back together and slowing the expansion down. But in 1998, scientists measuring distant supernovae realized the exact opposite was happening. The expansion was actually accelerating. Something was stepping on the cosmic gas pedal. That mysterious driving force is what we call dark energy, and it makes up nearly 70% of everything in existence. Dark matter, which is the invisible scaffolding holding galaxies together, is about 27%. That leaves the stars, planets, gas, dust, and you and me, the observable matter we can actually interact with, as just a tiny 5% sliver of reality.
Section 3. Cracks in our cosmic model.
So for a long time, our standard model of cosmology, that 68-27-5 ratio, seemed incredibly solid. It elegantly explained the Big Bang, the expansion, the cosmic microwave background, the whole shebang. But recently, massive cracks have started to appear in the data. The universe just isn't behaving exactly as our math says it should. For instance, a recent monumental analysis of 140 million galaxies by the Dark Energy Survey compared the standard model, where dark energy is a flat, constant force, against an evolving model where it changes over time. And they found that matter clustering isn't acting as perfectly predicted by the standard model. This gap suggests that dark energy might actually be evolving or even sputtering over time, rather than just remaining constant.
And then, add to this the recent discoveries by the James Webb Space Telescope. When peering back to just 400 million years after the Big Bang, it's finding early galaxies that are way too big and way too bright. It's finding black holes that grew far too quickly for our current models to explain. The early universe was just too active and moving way too fast.
Section 4. Expanding into what, exactly?
With our standard model struggling to explain these anomalies, theoretical physicists are now pushing past the boundaries of the observable universe to answer our core question. If dark energy is evolving and the Big Bang happened too fast, what is this all expanding into? What's the larger structure of reality? Well, one cutting-edge theory, detailed in recent preprint papers, is the bubble theory.
It suggests our universe is essentially a three-dimensional bubble expanding within a vast, pre-universal quantum fluid ocean. In this framework, that external medium could actually be the trigger and the driving force for dark energy itself. So the expansion of space isn't just an internal property. It's a reaction to the higher dimensional fluid we are expanding into.
This actually aligns perfectly with theoretical physicist Alan Guth's theory of eternal inflation. As Guth explains, that initial burst of exponential expansion doesn't just happen once. It creates an endless multiverse of pocket universes, constantly bubbling into existence. Our universe is just one tiny bubble in a remarkably vast, eternally expanding block of space-time.
Section 5. The Ultimate Fate. But this brings us to a rather chilling question. If this endless accelerated expansion never stops, pushed outward forever by dark energy, what is the ultimate destiny of our reality? Where does the timeline end? Following the physics to their logical conclusion, eventually we hit what's called the heat death or the big freeze. In the degenerate era, the supply of gas exhausts and all the stars die out. Then comes the black hole era, where only supermassive black holes remain in a pitch-black void. Finally, even those black holes slowly evaporate via Hawking radiation. The universe then enters the dark era, an infinitely diluted, freezing dark gas of stray massless photons.
Section 6. A universe reborn?
I know, that sounds incredibly bleak, doesn't it? An eternity of cold nothingness. But just when things seem completely dead and empty in the deep, remote future, theoretical physicist and Nobel laureate Roger Penrose offers a truly mind-bending final twist to our story. Penrose points out that in the distant dark era, all matter has decayed. Only massless particles like photons remain. And here is the absolute magic trick of relativity. Because photons have no mass, they do not experience the passage of time. They don't experience distance. For a photon, a journey of 1 trillion years across 1 trillion light-years happens in an instant. A universe without mass literally has no internal clocks. Because it lacks mass to keep time or measure scale, this infinitely large, cold universe becomes mathematically identical to an infinitely small, dense singularity. As Penrose says, the universe literally forgets how big it is. It loses all sense of scale. And in that mathematical trick of geometry, that vast empty space becomes the precise starting conditions for the next Big Bang. So the end essentially becomes a new beginning. We start by asking what the universe is expanding into, and we find that it might just be expanding into its own rebirth. This leaves us with a massive thought. Is our rapidly expanding universe, with all its galaxies, dark energy, and mysteries, just one single breath in an eternal cosmic cycle, waiting to be born all over again? Thank you so much for exploring this explainer with me today. Keep looking up and keep questioning everything.